Hello, so what we will do today is something about reducing a game into a 2x2 game by graphical method. We have seen that if we have a 2x2 game, we can easily employ the formula as given in the yellow box over there on the top of the screen. We can use that to determine the probabilities for the optimal strategies. But what happens if the game is not a 2x2 game? Surely because a player may have different strategies, so many strategies, he may have more than two strategies. So that is why we need some methods how to solve those types of games. So over here what we will do, we will be having 2 by n games, and we will also have m by 2 games. So over here what do you mean by 2 by n games? It is very simple. It just means that the payoff matrix is a 2 by n matrix. So you will be having something like this, where player A has two strategies, whereas player B has n strategies, B1, B2 up to Bn. So if you have this kind of a game, we will be using graphical method to solve the game. We will convert it into a 2 by 2 game. So over here we can write the elements as A11, A12 to A1n, and A21, A22 up to A2n. Okay, so this one we are going to do it by using graphical method. Similarly, for a game that looks like this, so over here we will be having two strategies for B and m strategies for A. So A1, A2 up to Am. The theory for this one and this one, they are similar. Of course there will be some changes, but they are very similar. So what I will do is I will explain this portion and I will send the notes for this. Okay, I hope that is fine. Okay, so let us start with this game. We also have to keep in mind that right now we are doing games without saddle point. Okay, so I will write the heading. The heading is solving a 2 by n game without saddle point. Over here will be the theory as well as the method, how it works, and also how to do it. Okay, so let A1, A2 be the strategies for player A, and let B1, B2 be the strategies for B up to Bn. Let them be the strategies for B. So let in fact I should be writing this A1, A2, P1, P2, and okay, the writing is similar up to Bn, Q1, Q2 up to Qn be the optimum mixed strategies for both players. So what do we have to do over here? We will have to find the probabilities P1, P2 and Q1, Q2 up to Qn. Also we will have to find the value of the game. Okay, but since we will be converting it into a 2 by 2 game, so the value of the game we can easily use the formula in the yellow box. Okay, so let the payoff matrix be let it be this one, A1, A2, what I've written, A12 to A1n, A21, A22 up to A2n. Now what we will do is this. Okay, so we will assume that B uses the strategy B1. we will assume that B uses the strategy B1. We will see what is the payoff for A. And also we will assume that B uses the strategy B2. What is the payoff for A? Okay, so this is what we will write. So it's like we have to find the payoffs for A. Okay, we are assuming B's strategy, B's payoff, A's payoff. This is what we will do. So when B's strategy is B1, A's payoff, it will be P1 times A11 plus P2 times A21. Okay, so this is what we will get. In fact, P1 plus P2 is equal to 1 because the sum of the probabilities is equal to 1. So we can easily convert P2 into P1 plus 1 minus P1 A21. If you simplify this one, P1 A11 plus 1 minus P1 A21. If you simplify this, you will be getting A11 minus A21 P1 plus A21. So this is what we will be getting. Similarly, if B's strategy is B2, we will be getting that A's payoff is, instead of A11, it will be A12. Instead of A21, it will be A22. P1 plus A22. We can continue this one up to Bn. So if we continue it up to Bn, over here we will be getting A1n minus A2n P1 plus A2n. So these are the payoffs for A when B is using the strategy B1, B2 up to Bn. Okay, accordingly. So now, what can we notice from over here? We notice that A's payoff depends only on the probability P1. Okay, for each strategy that B is using, A's payoff, it depends only on P1. That is what can change. That is, this probability P1, it's like a variable. It can change, but it can only change from 0 to 1. Okay, the probability P1, it can only lie in between 0 and 1. Okay, because these numbers, they are all fixed from the payoff matrix. So what will we do in this case? Since we are trying to use graphical method, that is exactly what we will do. These are called payoff lines. Okay, these things. Okay, each and every one of them, they are called payoff lines. Okay, in fact, if you have to denote this one, you will denote it with E1, P1. And if you have to denote this one, you will denote it with E2, P2. Similarly, if you have to denote this one, you will denote it with E2, P1. En, P1. Okay, if you have to denote. But it is fine even if you do not denote it, but at least the technique, it should be correct. So what we will do now, I will write this line. We will plot the payoff lines. So over here we will be getting so many payoffs, 1, 2, up to n. We will be getting n payoffs. Now what we will do is, we will plot the payoff lines E1, P1, E2, P1, up to En, P1. Why exactly do we call them payoff lines? Because if you see this one, it is like the equation of a line. Okay, remember the equation of a line we use right as y equal mx plus c. So this looks exactly like that, but instead of m, we are having a1n minus a2n, and instead of C we are having A to N, and instead of X we are getting P1. So now what we will do is this. Since we have to plot the payoff lines, so each and every one of these is a line. Now we will plot it. How we will plot it? By setting values of P1, okay, because P1 can take value between 0 and 1. So this is what we will do. Okay, I will draw two lines over here. It will become clear. Okay, this is the 0 level, 1, and over here 1. Similarly, over here 2. Over here we'll have 2. Okay, minus 1, minus 1, minus 2. Okay, and so on. Okay, you can even extend this line. So this is the line when P1 is equal to 0. When P1 equal to 0, we will be having this, and this is when P1 is equal to 1. Now what we will do is we will plot these lines. Okay, sometimes you may be having lines like this. Okay, this may be E1, P1. Okay, it differs depending upon the payoff matrix. This line may differ, okay, but this is just an illustration. So you will be having something like this. Okay, maybe this one is E2, P1. Sometimes you will be having something like this. Okay, and sometimes you will be having, okay, maybe something like this. Okay, okay, we will reach up to another point. So what we will do, we will plot all of these. We will draw all of these lines. Okay, we will draw all of these payoff lines. Now you notice that there is this lower portion. This lower portion, it is called the lower envelope. What exactly does this lower envelope gives? It gives us the minimum payoff for player A. Okay, the minimum payoff that player A can achieve is only over here. Okay, so this lower region represents the minimum payoff. But since we want to maximize the minimum payoff, we will choose the highest point in this lower envelope. That will give us the maximum point. Okay, so choose the highest point. Choose the highest point in the lower envelope. This point corresponds to the maximum point. Okay, so if you see from this figure, okay, the maximum point, it is formed by the intersection of two lines, right? So I will write something like this. The maximum point is obtained as an intersection of two payoff lines. Okay, maybe remember that how many payoff lines we were having? We are having n payoff lines. We are having E1, E2 up to En. But only the intersection of the two payoff lines, okay, will give the maximum point. So now that we have, okay, let these two lines be. Let these two lines be E. Okay, maybe E. Okay, we can use any notation. Maybe EA and EB. Okay, let the payoff lines be EA and EB. So what exactly will we be having? Then, okay, out of these two lines, EA and EB are from over here. So A can take the value from 1 to n, and similar B, it can be one of these. It can be 1, 2, or it can be n. Okay, depending. Then the game is reduced to and 2. Remember that before we were having a 2 by n game. Now what we will do, we have reduced the game into a 2 by 2 game. We have reduced it into a 2 by 2 game, and the game and the payoff now looks like this. We have eliminated so many of the strategies. What we will be having now is only the strategies BA and BB. Okay, maybe okay, instead of A and B, I will be using K and L. Okay, it will look better. Okay, we will be having only the strategies BK and BL. So now the payoff matrix, it will be reduced to A1K, A1L, A2K, A2L. So now if we want to solve the game, we can solve this one by using that formula that I supplied in that yellow box. Okay, so this is how we use the graphical method to solve a 2 by 2 game. But also you have to be very careful now, because if you remember right from the beginning, we have said that the optimum strategies are A1, A2, P1, P2. Fine, this is fine. Okay, we can find P1 and P2 by using the formula as given. But now remember that B has so many strategies, B1, B2 up to Bn. So many of these strategies have been eliminated. All of those strategies that have been eliminated, they will have the probabilities 0. So the only thing left will be the strategies BK and BL. This one will have probability PK and PL. Okay. Otherwise, each and every other strategy, it will be equal to 0. Okay, so we reduce it to a 2 by 2 game. We will solve it as a 2 by 2 game. The rest of the probabilities becomes 0. Okay, I will solve one problem and then you can see. Okay, I will actually take an example from the book. Okay, let's see. Solve the game A1, A2. Okay, 2, 1, 0, minus 2, 1, 0, 3, 2. Okay, we will solve it graphically. Even if it doesn't say that you have to solve it graphically, you just know that we have to do it in that way. But first, we have to be very careful because we are solving these type of games for games without saddle point. So the starting point will actually be the same. Okay, we will first check whether it has a saddle point or not. Okay, row minimum, row minimum, and column maximum. Okay, the row minimum over here will be minus 2. The row minimum it will be 0. Column maximum it will be 2. Column maximum it's 1. Column maximum it's 3. Column maximum over here again it is 3. So no saddle point. Minus 2, 0. So the game has no saddle point. Okay, if it has no saddle point, we have to use other methods. So this is the method that we will be using, that is graphical method. So let's see, 2, 1, 0, minus 2 and 1, 0, 3, 2. Okay, so sorry, I made a mistake. Over here it should be 1, 0, 3, 2. So now what we will do is that A1, A2, P1, P2, and B1, B2, B3, B4. As you can see, B has so many strategies. Okay, has 4 strategies. So this is what we will be writing, that these be the optimum strategies for player A. Okay, so once you write this, now what we will do, we will try to plot the payoff lines. Okay, so first we will have to obtain the payoff lines. Next, we will plot them. B strategy, A's payoff. So E1, it will be 2P1 plus P2. If you see the question, okay, from the payoff matrix, you will be having this 1P1 plus 0P2, and then 0P1 plus, okay, how did I get these numbers? It is from the payoff matrix, 0P1 plus 3P2, and over here we will be having minus 2P1 plus 2P2. Okay, so this is what we will be getting, but just remember that P1 plus P2 is equal to 1. Okay, similarly, Q1 plus Q2 plus Q3 plus Q4, it's equal to 1. Okay, so this is what we will be getting. Okay, just I will write it directly. P1 plus 1. Okay, change P2. P2, you can write it as 1 minus P1, so you will be getting it like this. Okay, I will write it directly. You will be having P1 only, minus 3 P1 plus 3, and over here you will be getting minus 4P1 plus 2. So this is what we will be having after converting the payoff only with one variable, that is P1. Now we will plot the payoff lines. Okay, if you want to be more accurate, you can use a scale or a ruler. Okay, but I won't be using it. Okay, let's see. I will be needing. Okay, so now we plot the graph. Okay, 0 level. Okay, just see for this one. When P1 is 0, so you will be getting the value 1. When P1 is 1, you will be getting the value 2. So you join the line from 1 to 2. So this one will be your P1. Now this one, when P1 is 0, P1 is 0, and P1 equal 1. When P1 is 0, you will be getting 0, and when P1 is equal to 1, you will be getting 1. So you will be having a line like this. Next, look at this one. P1 is 0, you will be getting 3, maybe somewhere over here, it will be 3. And when P1 is 1, you will be getting 0. So something like this. This one will be E3. Next, for this one, P1 is 0, you will be getting minus 2, okay, minus 1, minus 2, and over here, when P1 is 1, you will be getting, when P1 is 1, you will be getting 2. When P1 is 0, you will be getting 2, and when P1 is 1, you will be getting minus 2. So from 2 up to minus 2. As you can see over here, now this one is E3 and this one is E4. Okay, so from this graph we can see that this portion, it is the lower envelope. The highest point in the lower envelope is this. Okay, so what I will write now is the maximum point. The maximum point is the intersection of E2 and E4. Okay, hence the game This one is the maximum point, hence the game is reduced to a 2x2 game. So we have seen that the maximum point is obtained by the intersection of the lines E2 and E4. So that is why the payoff matrix, it is reduced to this matrix A1, A2 and B2, B4. B2 because of E2 and B4 because of E4. But what should we fill over here? It is these values 1, 0, minus 2 and 2. So it is reduced to this matrix. So because it is reduced to this 2x2 matrix, now we can actually use that formula in that yellow box. So first we will find lambda. Lambda will be the trace of this matrix, which is 1 plus 2 minus the sum of the anti-diagonal elements, minus 2 plus 0, which is 5. And we can also find P1. P1, if you take a look at the formula, it will be by lambda. A22. A22 will be 2 minus 0. So it will be 2 upon 5. And similarly, we can find P2. Similarly, we can find P2. P2, it will be 1 minus P1. It will be 1 minus 2 by 5. It will be 3 upon 5. So this is how we find the values of P1 and P2. But over here, we should be very careful. Because if you take a look at the formula, you are seeing the quantity Q1. But over here, it won't be Q1. It will actually be Q2. Because the corresponding strategy for B2, it is Q2. And the corresponding strategy for B4, it is Q4. So that's why over here will be Q2. And just use the formula for in that yellow box. It will be A22, 2 minus A12. A12 will be minus 2 upon lambda, which is 4 upon 5. And instead of Q2, now we will be having Q4. Q2 and Q4. It will be 1 minus Q2. 1 minus 4 upon 5, which is 1 upon 5. Okay, so we have obtained these probabilities. What about Q1 and Q3? Because the strategies A1, B1 and B3 do not occur in this matrix, so that's why Q1 will be 0 and Q3 will also be equal to 0. Okay, what about the value of the game? Value of the game, V, it's equal to the determinant of this matrix, 2 upon lambda, which is 2 upon 5. Okay, so we can just conclude, hence the optimum strategies. The optimum mix strategies, they are A1, A2. Just put the values of P1 and P2 over here, which is 2 by 5, 3 by 5, and B1, B2, B3, B4. Just put the corresponding values of Q1, Q2, Q3, Q4. So this is all. Okay, you can, now that you know how to solve this one, I will be sending you the notes for how to solve an M by 2 game. The one that we did was for a 2 by n game, but I will be sending you the notes for this M by 2 game. You will see that it will be very similar, so you can try out an exercise attached to those notes.